In 1485, more than 4 centuries before the first successful helicopter flight, Leonardo da Vinci sketched a flying machine with a rotating spiral blade designed to lift into the air. In 1495, he designed a humanoid mechanical knight powered by gears and pulleys, a concept that modern robotic engineers would later reconstruct and prove workable. In 1500, he described a parachute capable of safely lowering a man from great height. In the year 2000, that parachute was built and successfully tested. Leonardo da Vinci died in 1519. The airplane would not fly until 1903, the helicopter until 1939, functional robotics until the 20th century. So, how did a man born in 1452 imagine technologies that would not exist for 400 to 500 years? The answer is not myth. It is written in ink, across thousands of surviving notebook pages. Leonardo da Vinci was born on April 15, 1415, in Vinci, in the Republic of Florence. He is remembered as the painter of the Last Supper and the Mona Lisa. But during his lifetime, he was equally known as an engineer and military designer. Roughly 7,000 pages of his notebooks survive today. Scholars believe he may have written over 13,000 pages in total. These notebooks include detailed studies of anatomy, hydraulics, mechanics, flight, and military engineering. Many are preserved in collections, such as the Codex Atlanticus, housed in Milan's Biblioteca Ambrosiana, and the Codex Leicester, now owned by Bill Gates. They are not fantasy sketches. They are technical drawings, complete with measurements, cross-sections, and mechanical analysis. And several of them resemble modern inventions. Leonardo's obsession with flight intensified during the 1480s and 1490s while he was working in Milan under Ludovico Sforza. He carefully studied birds. He dissected wings. He analyzed air resistance. In manuscripts now grouped as the Codex on the Flight of Birds, circa 1505, Leonardo wrote that air has density and can be compressed, a crucial insight for aerodynamics. Around 1485, he sketched what he called an aerial screw. The design shows a large helical rotor made of linen stretched over a wire frame. The idea was that when rotated rapidly, it would screw into the air and lift off vertically. The principle resembles the vertical lift generated by helicopter rotors. There's no evidence it was ever built in his lifetime, and human-powered rotation would likely not have produced sufficient lift. But the mechanical concept, vertical takeoff using a rotating spiral surface, is clearly documented in the Codex Atlanticus. Centuries later, Igor Sikorsky would successfully develop practical helicopters in the 1930s. Leonardo did not invent the helicopter, but he conceptualized vertical rotary flight in the 15th century. That is documented fact. In the same period, Leonardo sketched a pyramidal parachute. In his notes, he wrote, "If a man has a tent made of linen of which the apertures have all been stopped up, and it be 12 braccia across and 12 in depth, he will be able to throw himself down from any great height without injury." A braccia was a Florentine unit of measurement. 12 braccia equals roughly 7 meters. The design is preserved in the Codex Atlanticus. In June 2000, British skydiver Adrian Nicholas constructed a parachute based strictly on Leonardo's specifications. Nicholas successfully jumped from 10,000 feet in South Africa, proving the design could function. This was not a redesign. It followed Leonardo's dimensions. 500 years later, the drawing worked. Around 1495, Leonardo designed what is now known as the Leonardo robot. The sketches were discovered in the 1950s in the Codex Atlanticus. The design shows a humanoid armored figure with an internal system of pulleys, gears, and cables. In 2002, roboticist Mark Rosheim reconstructed the design based on Leonardo's drawings. Rosheim concluded that the mechanism would have allowed the knight to sit, stand, move its arms, and open its jaw. This is documented in Rosheim's book, Leonardo's Lost Robots, 2006. There is no surviving evidence that Leonardo built the knight, but the mechanical logic is clearly drawn. It is one of the earliest known designs of a programmable humanoid automaton. Leonardo also designed a covered armored vehicle in 1487. The drawing shows a circular, turtle-like structure reinforced with angled plates mounted on wheels and equipped with multiple light cannons. Inside, cranks would power the movement. The design appears in the Codex Arundel. Modern historians note that the gear system as drawn contains a mechanical flaw, likely intentional, possibly to prevent misuse. Whether intentional or not, the concept of a mobile armored fighting vehicle predates the first tanks of World War I by more than 400 years. Again, it was never built. but it was clearly envisioned. Leonardo also sketched a diving suit around 1500 while in Venice. The drawings show a leather suit, mask with glass eye holes, and breathing tubes connected to a floating air support device. These sketches are preserved in the Codex Atlanticus. The context was military. Leonardo proposed that divers could sabotage enemy ships underwater. The idea of underwater breathing apparatus would not become practical until centuries later, yet the concept, flexible suit, air supply tubes, sealed mask, is visible in his drawings. Between 1489 and 1513, Leonardo conducted detailed anatomical studies. He dissected human cadavers in hospitals in Florence, Milan, and Rome. His drawings of the heart, muscles, skeleton, and vascular system are considered among the most accurate of the Renaissance. In 1507, working with anatomist Marcantonio della Torre, Leonardo studied the heart in detail. He correctly described the function of the aortic valve and the vortex motion of blood flow, something confirmed by modern cardiology centuries later. These anatomical notebooks were not published in his lifetime. They remained largely unknown until rediscovered, but the scientific accuracy is verifiable. Despite these designs, Leonardo did not create industrial machines. He lacked modern materials. He lacked lightweight engines. He lacked precision manufacturing. Most importantly, he worked alone. Many of his ideas were exploratory, theoretical investigations rather than production blueprints. His notebooks were private working documents. After his death on May 2, 1519, in Amboise, France, many manuscripts were scattered. Some were lost. Some survived by chance. It was not until the 19th and 20th centuries that scholars fully studied them. By then, many technologies he had sketched were finally becoming reality. Leonardo da Vinci did not build helicopters. He did not construct tanks. He did not launch airplanes. He did not publish most of his scientific discoveries, but he imagined them. Not vaguely, not symbolically. He drew them with measurements, with mechanical reasoning, with engineering logic. 5 centuries before powered flight, he studied lift. 4 centuries before robotics, he diagrammed mechanical automation. Centuries before scuba systems, he designed underwater breathing gear. He worked in a world lit by candles. He thought in centuries. When historians examine Leonardo's notebooks today, they do not see prophecy. They see method, observation, experimentation, relentless curiosity. Leonardo once wrote, "Saper videre," knowing how to see. That may be the real invention. Not the helicopter, not the robot, not the parachute, but the mindset that asks, what if, and then draws the answer. 500 years later, we are still catching up.